Hi guys, welcome back. Okay, so unlike the last time I said my video would be short, this time I'm not lying. So what we need to do is we need to graph this. So let's use the x-intercepts and the vertex to graph this guy, and then we'll just look at all the features of the graph and how they translate into this application problem. So John dove off a cliff into the water below along the arc defined by blah, 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 blah. This is h at t. This is not a multiplication. This is the value h, which is the height, based on the time t is equal to this formula, where h is the height above the water in feet and t is the time in seconds. So we're just going to label my graph here t and h right away. So I remember that relationship. And now I'm just going to factor that. So h at t is equal to, I'm going to factor the 2 that I see is common here, because that'll make it easier to factor it. 2 squared minus 10t plus 21. And so I need a number that multiplies to make positive 21, but adds to make negative 10. Those numbers are negative 7, negative 3. So it's going to be 2t minus 7, t minus 3. Notice that there's nothing in front of the t squared because I factored the 2 outside those brackets. Since there's nothing in front of the t squared, I can just take the 2 numbers that I find and pop them into the brackets. Call it a day. If I'm not sure, I may just FOIL this back out and then distribute the 2, see if I get what I started with, just to be sure. But all right, so now I can graph this guy. So let's do, I've got t equals 7 is one of my x-intercepts. T equals 3 is another. Let's find the midpoint between them, find the x of the vertex. So that's going to be x1 plus x2 divided by 2, which is 7 plus 3 divided by 2, which is 10 over 2, which is 5. And to find the y of the vertex, I will find the value of, it's x, it's t, whatever. To find the h of the vertex, I am going to plug the 5 in for t into the original equation, or the factored form, it doesn't matter. 2 times 5 squared minus 20 times 5 plus 42. So this does seem like a lot of work initially, but once you finish this work, you're done. Like, you just have to state stuff. And so then it's 2 times, that'll be 25, 5 squared, so that'll be 50, minus, that's 100, plus 42, so this will be minus 8. Okay, so that's my vertex point, is 5, negative 8 is my vertex. I'm also going to find the y-intercept. So I have my x-intercepts, I have the vertex, I want the y-intercept. So the y-intercept is going to be when t is equal to 0. So h at 0 equals 2 times 0 squared minus 20 times 0 plus 42, which is 42. We could have just looked at the constant term in the original equation. That would have helped us. So it's 0, 42 is our y-intercept. All right, let's put all this stuff on a graph. So I've got 0, 42. How do I fit that in? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes. If I made each box with 4, it still wouldn't be enough. So let's make each box worth 5. Yeah, that'll have to do it. Okay, so this will be 5, that'll be 10, and 15, 20, 25, 30, 35, 40, 45. So it's here. 42 is right about there, about almost halfway up that box there. That's 0, 42. That's the starting point, right? So that actually answers what the height of the cliff is, because here's the cliff, right? There's the cliff, and there's John standing at the top. And my stick figures are fantastic, I know. And then I've got t equals 3 and t equals 7. So 1, 2, 3, there's my x-intercept. 4, 5, 6, 7, there's my other x-intercept. And I have to graph my vertex, which is 5, negative 8. So 1, 2, 3, 4, 5. Notice it landed right between those two guys, dead center. Lovely. And I got to go down to minus 8. So it's minus 5, it's minus 10, so minus 8 is about there. I'm just going to label it. 5 minus 8. This is 7, 0. This is 3, 0. And so I'm just going to sketch my curve now. So and I could keep sketching up here, but that's actually not, like, unless he's like some sort of dolphin bird, man, he can't keep going up, right? He hits the water, he's under the water for a bit, and he resurfaces, and that's where his journey ends, right? John's done. So the height of the cliff, it's where he started from. This is beginning, it's his height at time 0, which is why I found this figure. So it's 42. 42 height above the water. Let's say it's in meters. Meters. The height of the cliff is. I just squeezed that in. I should answer in full sentences because, yeah. How long does it take for him to hit the water? What's the time from when he jumped at 0 to when he hit the water at 3, his first intercept? So 3 seconds. How long is he underwater? Well, he goes from 3 set time. Remember, this time is like someone hit a stopwatch, right? So it's from when the time reads 3 seconds to when the time reads 7 seconds is when he's underwater. So it's their difference. 7 minus 3 is 4 seconds. Is how long he's underwater. And how far below the water does John dive? Well, he dives down 8 meters. So don't say 8. He dives down -8 meters. You say he dives 8 meters below the water. Use your words. That's what I tell my kids. Use your words, child. Oh, the water. Okay, and there's an application problem. So it really is breaking down all the details of the parabola. What's its y-intercept? What's its x-intercept? Intercepts, excuse me. What's its vertex? Once you have that information, you'll probably be able to answer all the questions. Okay, thanks very much, guys, and I will see you soon.